Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is design a food rating system. Now, this is not just the object-oriented programming problem, this is a logical problem. You have to build a logic and you have to build the logic following the OOPS principle because you have to deal with the food rating class, you have to implement its constructor, you have to implement other methods of this particular class. So you should have some idea about the OOPS programming or the object-oriented structure in Python or in whatever language you are going to do it. Now, we have to design a food rating system that can do the following operations. It can modify the rating of a food item which is listed in the system, and it can return the highest rated food item for a particular type of cuisine. So basically we have to implement these two methods. The first method is change rating, which is going to change the rating of a particular food item to the new rating. So every food item will have a rating, and we have to find what's the highest rated item for a particular cuisine. We have to implement the food rating class. That's the class we have. In the food ratings class, the constructor is going to receive three different items or three different lists of the same size. The list will contain the foods, the cuisines, and the ratings. Using the constructor, we have to initialize our food rating system or the food ratings class. Now the food items are described by foods, cuisines, and ratings, all of which have length of n. That is, in the constructor you will be given a list of foods, a list of cuisines, and the list of ratings, and the length of all these three items are same. So basically the items at the same indexes are a food of a particular type of cuisine with a particular rating. Using the method void change rating, which will give you a food and a new rating, you need to change the rating of your current food item with the new rating. Let us say your food item is noodles and its initial rating was 4, and now using the change rating function you want to say for noodles the rating is 5 now. So you will have to change the rating as well based on whatever data structure you are storing your data, the initial data, the foods, the cuisines, and the ratings. And there is another method which is string highest rated, which will receive as an input a cuisine. Maybe you can receive a cuisine like Korean, and you have to find what are the different foods of those Korean cuisine and which of that food has the highest rating. So basically, out of all the foods in this particular cuisine, you have to return a string. Return a string or the food name which has the highest rating belonging to this particular cuisine. And if there is a tie, let us say there are two food items who have same rating, in that case you need to return the item with the lexicographically smaller name. Now the thing is guys, we have to focus completely on how are we storing the data. Try to think about it. We have a cuisine, right? A particular cuisine have many foods. Food 1, or let us say food 2, or let us say food 3. Three different types of food belongs to a particular cuisine, and every food has a rating. Let us say 10, let us say 20, and let us say 15. So this is the type of data you have, and you will have multiple cuisines, right? You have cuisine number 1, then you can have cuisine number 2 as well. You have multiple cuisine which will have different types of foods, and every food will have a rating. So this is the kind of relation, or this is the kind of data we initially have. Now we have to store the data somewhere, right? And storing part will be done in the constructor, the init function for Python. I think in Java we have the constructor as the same name of the class. So however you want to implement it, you can do it. But the whole point is, how do you want to store the data? Do you want to store the data in some kind of list? Do you want to store the data in some kind of dictionary or hash map or some kind of map, right? And definitely we have to make use of map. The reason is, if you store the data in a list, let us say I say that self.foods is equal to foods, and let's do the same for cuisines and ratings as well. The cuisines and ratings and the foods all are nothing but a list, right? We are just creating a list to store all these data. Now if I just want to change my rating, I will first have to go through all the foods to find out at which particular index my current food is at. The moment I'm able to find the index, I will go to that index and I will change the rating in my self.ratings list. But in this case, to change the rating, you will have to go through the entire list, right? What if I could just store the mapping of food to ratings? I can say self.foods is not foods now. Let's make it a default dictionary where every data in your dictionary is going to store an integer because the ratings are integer. So for every food, we are going to store the rating. Now I don't want to store the rating separately. What I can do is I can just go through the foods. I could say f comma r in zip. Let's zip the foods and ratings together, and then I can say self.foods of this particular food f. The rating is actually equal to r. So now what's the use of this? If you are storing this as a hash map or a dictionary, then changing the rating is a very straightforward process. The moment somebody calls this method change rating, you can simply say self.foods. You want to access this particular data, so self.foods. I can say for this current food, this is the new rating, right? So now the change rating method is actually implemented in O of 1 time complexity. You are not running any loop or something, you are just updating your map. But what about finding the highest rated cuisine? As of now, you are storing your cuisine as a list. If you store your cuisine as a list, so now first of all, you will again have to go through the entire cuisines to find out which cuisine this highest rated function is talking about. The moment you find the cuisine, now you have to find out what are the different foods which belongs to this particular cuisine. But the problem is you have not stored your data in such a way that you can just find out that, okay, for this particular cuisine, these are the different foods. So let's actually do it. Let's store the cuisines as a mapping as well. We can say the cuisines is a default dictionary and every item in the cuisine is a list. Why a list? Because we are trying to store all the different foods which belongs to this particular cuisine. And guys, right now we are just trying to focus on solving the problem in an intuitive way. We are not directly jumping on the solution. We are trying to build the intuition one by one. So let's focus on the cuisines now. I can say for C, F, R in zip the cuisines as well. Zip the cuisines, foods and ratings. Now the moment I am storing the rating of a particular food, I can also say self.cuisines, which is the default dictionary, dot append, and I can say append the food. Now what this can do is for a particular type of cuisine, I can directly get what are the different foods. And now using the different foods, I can find the different ratings, and out of those ratings, I can extract the highest rating for a particular food item and return that particular food item name. So let's actually do it. Our changeRating method is fine. Let's focus on the highest rated one. Now to find all the foods of this particular cuisine, I can directly say self.cuisines, which is a default dictionary now. So self.cuisines and pass this particular cuisine, and this will give me all the different foods because we have appended all the different foods here, right? And now I can just run a loop to find out what's the highest rated food out of all these food items. Let us say as of now my result is empty, the food name, the current rating I have is 0. And now let's go through all the foods for F in foods. These are all the foods which belongs to this particular cuisine. And now I can say if from the self.foods, if you pass this particular F, basically in the self.foods, you are storing the rating of a particular food. So if the rating of my current food, if that rating is more than the rating I already have, then in this case, I can say result is equal to F. This particular food has the highest rating, and the rating rat will be equal to self.foods of F. This is the highest rating I know about as of now. And there is another condition, elif, if these two values are equal. If the two values are equal, we have another condition, right? If you see here, if there is a tie between two food items who have the same rating, then we have to return the lexicographically smaller name. So I can say result, now the result is equal to the minimum of current food name and the already existing result. Now finally I can say return the value of result. Now this might solve a lot of test cases which I have in my problem. Okay, as of now it says that append is not a method of default dict, and the reason is we are saying that self.cuisines. We have to say self.cuisines and pass the key name. The key name will be C, right? So that's the key name, and now I can append my food. And this is not going to be food, but this is going to be F, right? This is the F we have. Now let me run this and let me see if it passes the sample test cases. So yes, you can see the sample test cases are fine. And if I submit this as of now, this is going to pass a lot of different test cases, but this is going to give us a time limit exceeded error. So yes, we can see the solution looks good and it is passing 73 out of 78 test cases, but it is giving us time limit exceeded error. And the reason is the changeRating method is fine, but the highest rated method is going through the entire foods of a cuisine, and this is taking a lot of time. Because what if all the foods belong to the same cuisine? Then you are basically going through the entire data, right? Now let us try to think about something which is more optimized. And if I just focus on the problem here, the problem says that I have to find the highest rating. If you need the highest data out of a list, let us say you have a list 1, 10, 5, 7 and 8. If you want to find the highest data, then you could just simply say, okay, 10 is the highest. But it is not just about finding the highest data about a list. This list values can change. They may say that, okay, the food item which had the rating of 5 now has the rating of 15. Now your highest is not 10, the highest is 15, right? So basically this is giving me a hint of using something called as a heap data structure. A heap data structure is a kind of data structure which can give you the minimum value in your data or the maximum value in your data at a particular time. And that is what we need. We need the maximum data in our list. If we have a cuisine and if we know that in that cuisine, these are the different food items and these are the different ratings, and we could store them in a heap. And then if somebody says, hey, tell me for this particular cuisine, what's the food which is highest rated? Then I could simply use the heap to find out the data, right? That, okay, the 15 is the maximum in my rating list, and this 15 is the rating of this particular food item. I will return this particular food item name, and that's it. And doing it with a heap is going to take log of n time complexity to find the highest rating. And even if I change the rating, then log of n will be used instead of O of 1. So the time complexity of change rating is going to increase, but the time complexity of highest rating is going to decrease, and this will be a significant decrease. So let's actually try this one. So now we have to store our data in a little bit different way. We can say that the cuisines are still a list, but when we store those data, we are not storing just the food item name, we are also going to store the rating, and we are going to do it using a heap. So let me import heap here. I can say import heap q, that's the module name in Python. And now instead of using this append method, I could use heap q dot heap push method. I want to push my data in the heap, and this is the list in which I want to push my data, which is self.cuisines of C. And in this list, I want to push my rating and my food item. Now I could say r comma f, right? This is going to push rating and food item, and while pushing, it is going to maintain the heap data structure so that we can directly find out what's the top rated item for a particular cuisine. But the thing is, in Python, when you use this particular heap q method, it by default act as a min heap, and to make it act as a max heap, we could just say when we are pushing the rating, push them in the negative way. Now this will act as a max heap. The data which is at the top will have the highest rating. Also, we have to do some change in the foods as well. In the foods right now, we are just storing that this is the rating. We also need to know this food belongs to which type of cuisine, and that is going to be important. The problem is all about how are you storing your data, how well can you store your data, and then you can apply the logic. So instead of storing just an integer, let's store a tuple, and let's make sure that when we are storing the tuple, we are storing the cuisine comma rating. So now we have stored some extra information in the foods, and we have stored the cuisines still as a list, but in the list every item is not just a food, it also contains the rating. When you change the rating, what really happens? So let us first find out what's the previous rating of this particular item. We don't really need it, but we need to know the cuisine of this particular item. So we can say cuisine comma rating from self.foods, and this is the food name. Now we know that we are in the foods, we are storing the cuisine and the rating. So we will get the cuisine and the rating of this particular food, and now we have to update this. So I could use this particular logic. I can say self.foods of this current food item. This is going to be updated. The cuisine name will remain the same. It will belong to the same cuisine, but the rating will now be changed to new rating, right? Updating this in the foods is fine, but we are also storing the rating in the cuisines as well, right? In the cuisines, we are storing that it belongs to this particular food, and this is the rating of it. Now the thing is, guys, there was a reason we had to store this cuisine in the foods as well. Now what we can do is we can use this self.cuisines, and we can pass this particular cuisine. Basically, this particular cuisine is telling me that the current food item for which you want to change the rating belongs to this particular cuisine. So in this particular cuisine, you will have to update the rating of this particular food item. But updating the food item will be like going through the entire list of foods. So let's not do it. Let's make use of heap q.heap push. Let's push another item in this particular list. This is our list, right? In which we need to push the item, and the data we need to push will be negative of rating and the current food name. We have the new rating with us, so we can push this new rating as negative, and this is the food item. Now you might have a lot of questions just by looking at this particular logic. Here we are pushing the data, right? We have to update the data, but we are pushing it. It means we are going to have some duplicate records in the cuisines. In the cuisines, for a particular food item, we will have multiple ratings. The real rating is in the self.foods for a particular food item, but in the cuisines we have multiple rating for a particular food, which is fine. We are going to deal with this. But now the highest rated method can be very straightforward. What we can do is, first of all, we can just say in the highest rated method we are given the cuisine. So let us find out what's the data this particular cuisine have. Every cuisine is a list in the self.cuisines, right? And every list is behaving like a heap, right? So I can say heap is equal to self.cuisines of this cuisine. From this cuisines dictionary, we are trying to find out what are the different data we have for this current cuisine. So this is the heap. Now if I say return heap of 0, so this is going to give me what's the highest rated item or highest rated food currently in my cuisines for this particular cuisine. And in every cuisine, we are storing the data as a rating and food item. So this is going to give me, heap of 0 is going to give me the rating and food item which has the highest rating, and I can take the value at index number 1 which will have the food name, and I can return this, and I can run this. This is going to pass a lot of test cases, but there is a problem with this logic. The problem is we are not removing the duplicate records, because while changing the rating we have added some duplicate records, so we have to remove the duplicate records as well, right? So before we return the food item name, what we could do is we could say while we have something in the heap, we have to remove the duplicate record, right? Now let us find out what's the highest rated item. So this is the rating, and this is the food name which is going to come from heap of 0, right? Because every data in my heap contains the rating and food item. So this is the rating and food item. We have to first find out, is this the correct rating for this particular food item? Correct rating is stored in the self.foods, right? So we can say if from the self.foods for the current food item, the rating belongs to the index number 1 because we are storing the cuisine and rating. So rating belongs to the index number 1. if this is actually equal to rating, it means it is the correct rating. If it is the correct rating, then you can return this. You can say return, this is the food. But if it is not the correct rating, it means it is the duplicate record. It is the record which should not be there. Then we can say heap q dot heap pop. Let's pop the item from the heap. Let's pop the top item from the heap, because that is a duplicate record. And before running this, when you are using this logic, you have to say minus rating, because we are fetching the rating from the heap, and while storing, we were storing it as a negative value, right? So while comparing, you will have to just convert it back to positive. Now this should do it. If you run this, you will see that the sample test cases are fine. If you submit this, this is going to pass all the test cases in a very efficient way. You can see the runtime is really good. The memory used is really good as well. So we have solved this particular problem in a very efficient way, guys. And let me just show you the entire code just by scrolling. You can pause and see the code at any moment. And we have solved this. So guys, that's it for this video. I have tried to explain you each and everything which you should know while solving these kind of questions. We have gone through step by step, because these kind of questions belongs to an interview question. And when you are solving an interview question, you cannot just directly reach to the solution. You have to go through step by step. So again, that's it for this video. If this video has helped you to understand the problem and the solution approach, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one, guys.